All right, so we're going to be going over the first day of polar graphing. So this first slide that you're looking at is basically kind of a summary using radians and degrees using a unit circle. Okay, so just to kind of explain this a little bit in case you're looking at it and it's a little bit confusing. As you can see so basically this first terminal ray right here, you can see that that's at 30 degrees, which is also known as pi over 6 in radians, okay? So now we're able to go back and forth between those two. Also on this, it is given a coordinate point at that location, and that again is based on a unit circle with that radius of 1. Okay, so the way that we get that value, that x comma y point, and that would be a rectangular point, would be by dropping that other leg down from the terminal ray, and then knowing that this reference angle is 30, which means that this one up here is 60 and 90. And then since my radius has to be 1, I know that my other sides would be root 3 over 2. And this would be 1 over 2, okay? And that's because the radius is 1. So from there, I could do this with all of my other reference triangles that I make, whether I'm at 45 degrees, 60 degrees, whether I'm at 2 pi over 3, all these possibilities, I could continue to make those. There are some other cool features that are on this picture. Well, first of all, you can see the different quadrants that you're in right here. And also it tells you with your rectangular points, so your x comma y points, whether it's positive or negative. We've gone over this before at the beginning of this unit, but it's just a cool feature that kind of summarizes everything into one picture. Alrighty, so now we're going to get into polar graphing, which is actually one of my favorite lessons to teach. So we're going to be plotting points on a polar grid. So we're used to a coordinate grid, but now we're looking at a polar grid, which you can see is circular. Okay, before I go on, why don't you go ahead and just pause this video and just write these points down that aren't included in your notes. So go ahead and pause. All right, so polar points are given to you in the form of your radius, so the value of your radius, comma, your angle, okay? And that angle, as always, can be in degrees or radians. It just depends on the situation, okay? So then, now looking at those points that you just copied down, if I looked at point A, so this is my polar point A, I have a radius of 2 and an angle of 5 pi over 6, okay? So I'm going to go ahead and just mark my polar grid so it's a little bit more clear. So every time that I have a red mark, I know you don't have color on your notes, I apologize for that, but these red marks are going to be my radius of 1, 2, 3, 4, 5, and 6. Okay, and then I'm going to go ahead and I'm just going to label in radians where my important, or my most common radians are. So I know that here I'm at 0 or 2 pi. Up here I'm at pi over 2. Over here I'm at pi. And down here I'm at 3 pi over 2. Okay. So I know that for point A, I need to be at 5 pi over 6. So to divide my pi into 6 pieces, I know that's going to be every other mark, basically. So that's 1 pi over 6, 2 pi over 6, 3, 4, 5, and then 6 pi over 6. So ultimately, this is my 5 pi over 6. So to plot A, what I'm going to do is I'm going to go 2 marks. So I'm going to go 1, 2, and then I'm at 5 pi over 6, so that's going to be my ultimate point for A. All right, so for point B, which I'll do in purple, so my radius is 4, and my angle is going to be negative 2 pi over 3. So if it's negative 2 pi over 3, I know that I'm going to be going in the clockwise direction, so the opposite direction. And if I divvy this up into 3 pieces, I'm going to go every 4th mark. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so then that's my third. So this is negative 1 pi over 3, and this would be negative 2 pi over 3. So basically I'm going to be along this line right here, and then my radius has to be 4. So I'm going to go, starting from the center, I go 1, 2, 3, 4, and there is my point B. Okay, what I'm going to encourage you to do is pause the video and go ahead and try to graph points C, D, and E. Okay, so if you got stuck on D and E, that's totally fine. Check out where C is. So C should be in this location, so 2 marks away from 180. And I figured out that basically to one of those first tick marks would be 15 degrees. So then I went 195, 210. But this one's different than the ones I instructed you. Maybe you figured it out, maybe you didn't, that's okay. But all that the negative radius means is that basically you shoot to the other side of the center of the circle. So let me explain what that means. So if I were to just graph this with a positive 1, so first I would go to my 3 pi over 4, which is here, and I would have graphed that initially at this point, right? But since it's a negative radius, what that means is I just go in the opposite direction then, okay? So instead of graphing this point and this being my answer, I go back to my center and I move the opposite direction 1. So then ultimately D is in this position, okay? And then similarly for E, I also had a negative radius. So again, first I treat it as a positive, and then I go to pi over 12. So pi over 12 was here. This would be where my radius of 6 would be, but my radius is negative. So therefore I'm going to track back along this line, and I'm going to go to the opposite side of the center of my circle. So then this ultimately is my E, because it's directly across from my original point if my radius was positive. So I'm right here. All right, so one of the skills that you're going to learn right now, which is what you're going to be tested on, is basically going from polar to rectangular points, okay? And just a reminder that polar is r comma theta, whatever that degree is, or radian, and then rectangular is x comma y. And then going from rectangular, x comma y, to polar, r comma theta, okay? So one of the first things that we need to just look back at is looking at our 2 trig functions that help us figure out what x and y are. So I know that cosine theta is equal to x over r, and then I know that sine theta is equal to y over r, okay? To find out what x is by itself, I know that I simply just have to multiply both sides by cosine of theta. So ultimately this is what my x would equal, no matter what the radius is. And my y, same thing, multiply both sides by r, would be r times sine of theta, okay? So ultimately, if I'm given a radius and if I'm given an angle, I could then turn anything, if I plug it into this form, r times cosine of a, comma, r times sine of a, that will turn it into an x, comma, y point for me. So, for example, if I have this first point, so 2 comma 135, so this is a polar point where it's r comma theta. If I were to graph this, well, first of all, I know it's in the second quadrant because it's an angle of 135, which means that this would be 135 and this would be 45 degrees. So I've got a 45, 45, 90 triangle, and my radius in this case is 2, okay? So I could do some mental math and figure out that this needs to be negative root 2 and this needs to be root 2. Knowing this, then I know that my x comma y point would just be negative root 2 comma root 2, okay? So, but in this case, you do have your calculator, okay? So if you wanted to, you could use what we just talked about, r times cosine of a and r times sine of a. And I could plug this in and say that r is 2 times cosine, and my angle in this case would be 135. So I'm actually going to use the angle that was originally given to me. And then I can do the same thing for my y value. So I'd plug in my radius of 2, and then this time I'm using sine instead of 135, okay? And you can plug this into your calculator, okay? So if you do that though, please make sure that you are in degrees. So go to doc.calc document settings, and then make sure you're in degrees. Okay, and then ultimately this should lead you to negative 1.41 comma 1.41. So I rounded that to 2 decimal places, which you could also do if you wanted to. And these values ultimately equal the exact same thing as negative root 2 and 2. It's just rounded. Okay. Go ahead and why don't you try the second one? So pause the video and then I will write the answer down. Okay, so just to quickly explain what I did. So I knew that this was 7 pi over 6, so it was just past 6 pi over 6, which is pi. So I knew that was in the third quadrant with a reference angle of pi over 6. Okay, so I know that this is a pi over 6, pi over 3, pi over 2 triangle, and I could have done the sides with my head, and that's totally fine. Or you could just use your calculator. But again, this is in radians now, so you must change your settings, and you can plug in the number pi as the full value of pi. It's in the bottom left of your keypad, okay? So when I plug this in, ultimately, depending on what settings your calculator is in, it either gave you the exact value, which was with the root 3, or it gave you an approximate, which was the decimal. Okay, either one of these would be totally okay, and then just general rule of thumb, round to 2 decimal places. Let me just go ahead and put that in the notes for those of you that are cruising through. Round to 2 decimal places. So that's only if, again, your calculator is just giving you an approximate, but this would also be an okay answer. Okay, so both of these are acceptable. So now we're going to move on to going from rectangular x comma y to polar r comma theta. So I just zoomed in on this slide so it's a little bit easier for me to write. Okay, so this is my first x comma y point. Okay, so I'm just going to go ahead and graph that. So I know that that's going to be in my fourth quadrant. 1, 2, 3, negative 2. Here's my point. Okay. So then 3 and negative 2. I can figure out what my hypotenuse is by just using Pythagorean theorem, which is my first step, and that ultimately will help me find my radius. Okay, so 3 squared is 9, plus negative 2 squared is positive 4. So that's going to give me the square root of 13. Okay, so now I know that my first part of my answer is a square root of 13, and then I just need to find my angle. Okay, so I know that my angle will ultimately be, if I started from my initial ray and I went all the way around, so ultimately it's going to be 360 minus whatever this little reference angle is. So in order to find that angle, what I can always use is I can use tangent. Granted, now that I have all 3 sides, I could use sine or cosine, but tangent might be a little bit easier because you're always given smaller values. Ooh, sorry, I don't know why that was moving around. Okay, so I have tangent of my theta is equal to negative 2 over 3. So I'd plug this in my calculator of tan negative 1 of negative 2 over 3. And that should give me theta. So again, depending on what your calculator is giving you, it's going to give you either radians or degrees. So just be conscious of that, okay? So my calculator is in degrees, and when I plug this in, I ended up getting a reference angle of 33.7, okay? Do not make the mistake of now just putting this into my final polar answer. I know that earlier I said that it was 360 minus 33.7. Now this answer will give me 326.3 degrees. And this is now the answer that I can plug into my final polar answer. Okay. So then this is my final polar answer for this first one. Okay. Go ahead and try numbers 2 and number 3 on your own, and then I'll have the answers up. So go ahead and pause the video and try those on your own. All right, so go ahead and check your answers here. So I just did it in the exact same method. I just first drew the picture and then figured out what quadrant I was in. And then I just noticed to see if it was 180 minus or plus or 360 minus or plus. Just note that my answers are all written in degrees, okay? You can do this in radians as well. The key is to just switch out, instead of saying 180, you'd obviously just say pi instead. So you do pi minus whatever you got for this reference angle, okay? And then this one would be the same thing. Instead of 180, you'd say it was pi plus that reference angle, which is this guy right here, to get you that final answer, okay? Okay, so this next part is going to be pretty fun. We're looking at the radius and theta in different situations. So the first situation is saying, what if the radius was just always 3? Okay, so if I just make a quick table, this will help me with all 4 of these graphs. If my theta was 0, my radius would be 3. If theta was 0.785 radians, it would be 3. 1.57 radians, it would be 3. Pi, so 3.14, 3. 6.28, so 2 pi, 3. If I were to graph these, okay, and sorry, I forgot to mention that I have already written just these benchmark numbers in terms of radians, because this will help me with all of my charts. So I'm just doing this all in radians because it'll be a little bit easier to deal with. So if I go ahead and if I just mark these real quick, let me do that in black. This would be a radius of 1 again, 2, 3, 4, 5, and 6. So at all those places, if I just plot those points that I just talked about, all with a radius of 3, my final graph, ooh boy, this is not looking good. But ultimately it would just be a circle. Okay, so my next one is going to be pretty interesting, because what happens when my radius equals my theta? Okay, so again, let's just start with our theta. So if theta is 0, that means my radius is 0. If my theta, so in radians, was pi over 4, which is 0.785, that's also my radius. If it's 1.57, so pi over 2, radius is also 5.17, 1.57. 2.355, which is 3 pi over 4. Same thing here, pi. 4.71, which is 3 pi over 2. And all the way back to 2 pi, 6.28. So let's graph these. So 0, 0, easy enough, I'm here. 0.78, so that's along this line right here. And then I'm going to go to 0.78, which is somewhere in here. And then 1.57, so this is around 1.57, in between 1 and 2, and on 1.57. 3.14, so I go 1, 2, 3.14 is about right here. 4.71, 1, 2, 3, 4, 4.5, so 4.71 is somewhere here. And then finally 6.28, which is a little bit off the grid here. So if I were to connect these, oh boy, let's see if I can handle this. It's actually going to be a nice little swirl. Okay, pretty cool, right? All right, so the next one I'm going to do a similar thing, but now it's saying that theta will just always equal pi. So no matter what my radius is, my theta will always be pi. So whether I'm at 0 or 1 or 2 or 3, I'm at pi. So I'm at 0, 1, 2, 3, and I could just keep going. So ultimately, this is just going to lead me in a line in this direction forever. All right, so my last one's a little bit special. So I'm actually just going to use a blank grid and get rid of all these other ones so I can explain it a little bit better. All right, so this one says that my radius will always equal to sine of theta. So my radius is going to continuously change depending on what theta is. Okay, so first thing I can do is just plug in 0 for theta. So if I plugged in 0 for theta, so this would be sine of 0. Well, sine of 0 I know is just equal to 0. So I'm actually just going to be right here to start. So then the next benchmark angle, and again, I'm just going to do this in radians, would be sine of pi over 4. And I know pi over 4 is roughly 0.785, but if I plugged it in my calculator, I'd want to use the exact value of pi. Okay, and then this would actually give me 0.5. Okay, and again, theta was that pi over 4, which was that 0.785. And then to graph that, I'm at the 0.785, so I'm right here. And then I would go halfway, which is at this point right here. Okay? And then next, I'm going to do my next benchmark, which is sine of pi over 2. And if I plug this into my calculator, I'm actually going to get the value of 1, because sine of pi over 2, my y value is 1 at that point. And then my theta that I plugged in was pi over 2, which again is at 1.57. And then if I were to graph that on my polar graph, this is 1.57, and I'm going to go to 1. Next then, I'm going to plug in sine of 3 pi over 4. So then this is 3 pi over 4, which is approximately equal to 2.355. And I know that that value is also going to give me 0.5. So we're going to start to see a pattern emerge here. But again, so I'm at my 2.355, which is right here, and I'm going to go back to 0.5. So I've actually made myself a nice little pedal here. I'm going to guess that my next one is going to go to 0, but let's check it out. So sine of pi, so then my theta is pi, and that's going to get me indeed back to 0. So then I can finish off this pedal, looping it back to that 0. Okay. If I kept going, just quickly, I know that sine of 3 pi over 2 is 1. And I know in between that will give me 0.5 and 0.5. So I will actually get a pedal like this. Okay. And we're going to talk about graphing these types of pedals because they actually vary. And we're going to talk about that all next class. So that's going to be in Polar Graphing Day 2. Okay? All right. Well, I hope you enjoyed this lesson as much as I did. I love polar graphing. It's a lot of fun. And I will see you guys next class for Day 2.